Okay, let's work through some examples in 6.1. So in 6.1, they give us two numbers to begin with, and they ask us to find the greatest common factor. So remember what a greatest common factor is what is the largest number that goes into both of them. Remember, factors are things that are multiplied together. So we could just take the time and list factors of 16 and factors of 88. 16 is 1 times 16, 2 times 8, 4 times 4. So 1, 2, 4, 8, and 16 are all factors of 16. 88 is 1 times 88, 2 times 44. 3 doesn't go into 88, but 4 goes into 88. 4 times 22. 5 doesn't go into it. Um, 6 doesn't go into it. 7 doesn't go into it. 8 goes into it 11 times. So the factors are 1, 2, 4, 8, 11, 22, 44, and 88. And that's okay to do that. And we just look to see which factor is the biggest one, the greatest one they have in common. So let's start with the smallest. The largest number that's a factor of 16 is 16. Well, 16 is not in the right list, so that's not a common factor. What about 8? Is 8 in both lists? It is. It is in both lists. So 8 is the biggest number that both lists have in common. In other words, 8 is the greatest common factor. Now, as numbers get larger and larger and larger, that's going to be more and more difficult. So let's look at another technique to do that. Let's make another page. And again, let's look at 16 and 88. So probably the best way to find the greatest common factor is to begin by listing the prime factorization. 16 is 2 times 8. 2 is prime. 8 is 2 times 4. 2 is prime, and 4 is 2 times 2. So the prime factorization of 16 is 2 times 2 times 2. And remember, that's unique. There is a unique list of prime numbers that when you multiply them together make 16. 88 is 2 times 44. 2 is prime. 44 is 2 times 22. 2 is prime. And that's 2 times 11. So the prime factorization for 88 is 2 times 2 times 2 times 11. So the way we figure out what is the greatest common factor is we look to find out what all do these two lists have in common. Both of them have a 2. Both of them have another 2. Both of them have another 2. Now they don't both have 4 2's, and they don't both have an 11. So both sets have 3 2's in common. That's something that is similar in both sets, is 3 2's. Well, notice 2 times 2 is 4. 4 times 2 is 8. So we can get the greatest common factor that way. It's what all out of the prime factorization do they have in common. Now let's look at one that has letters instead of numbers. So as we look at these, we wouldn't want to have to sit down and write out all of those y's, and all of those y's, and all of those y's. Because remember what y to the sixth means. It means y times y times y times y times y until we have 6 of those. So this one has 6 factors of y, this one has 9, this one has 7. So if we're looking for the greatest common factor, we want to know how many y's do all of them have. Now some of them have more y's, but each of these have at least how many? So the first one has 6. Does the next one have 6? Yeah, the next one has at least 6. Does the next one have 6? Yes, the next one has at least 6. So our greatest common factor is y to the 6th. Each of those have at least 6 y's. They don't have any more than that. You might say, well, do they all have 7? Well, this one has 7, but this one, oh, I'm sorry, let me erase that. And this one has 7, but this one doesn't have 7. That one only has 6. So the greatest common factor is the most things that they all have that are the same. So they both all have at least 6 factors of y. Let's take a look at this one. So in looking for the greatest common factor, each of these have both x's and y's. So we need to look at them separately to see how many x's do they all have, how many y's do they all have. So the first one, you may notice, the first one has 14 x's. But do all 3 of them have 14 x's? Well, no. This one only has 2. And this one has 5. So do they all have 5? No, they don't all have 5, because that one only has 2. But all of them have at least 2 x's. So that's the most number of x's that we could write down that is something they all have in common. Now, how many y's do they have in common? Do they all have at least 5 y's? Well, that one has 5. That one has 5. What about this one? Does that one have at least 5 y's? Well, yes, that one has at least 5 y's. So the most that they have in common is they all have at least 5 y's. So that's our greatest common factor. Now the next one has both numbers and letters. So let's start with our numbers first. If we look at 245, I tell you what, there's several ways we could go about doing this. We could list the prime factorization of 245 and then the prime factorization of 35 and then a 5. Let's look at the smallest coefficient. The smallest coefficient is 5. So that means the biggest number that they could all have in common is 5. You say, why is 5 the biggest? If we said 6, is 6, does 6 go into 5? Does any number that's bigger than 5 go into 5? No. So if we're looking for what factors they all have, the only prime factor that 5x to the 7th has is 5. So we have to ask ourselves, is 5 a factor of the other two? Does 5 go into 35? Well, yes, 5 goes into 35. How do I know that? Well, first of all, that's one of our multiplication things we memorize. 35 is 5 times 7. But also, if that last number is either 0 or 5, then it's divisible by 5. Same thing here. That number is a 5, so it's divisible by 5. So 5 goes into 245, 5 goes into 35, and 5 goes into 5. So for our coefficient, the biggest number that goes into each of those coefficients is 5. And I'll say this again, you might look at it and say, well, 5 is the smallest number. Out of those, 245 is the biggest. But does 245 go into 5? No. So 245 is the biggest coefficient, but that 245 is not a factor of 5. It's not something that goes into 5. But 5 is a factor of 35. 5 goes into 35. 5 is a factor of 245. 5 goes into it. then look at our x's. So how many x's do they have in common? They all have at least 5 x's. Some of them have more, but they all have at least 5. So that's our greatest common factor, 5x to the 5th. And hopefully, as we do some of the rest of these problems, it'll also make our common factors make even more sense. Remember, a factor is just a product. As we looked at the very first example, we were writing numbers as products of two numbers. So we're looking for something times something that makes each of these. And what's the biggest number they have in common? Well, let's look here for our greatest common factor. And then we're going to go farther than that. We're not going to just stop at finding the common factor. We're going to use it to write this as a product. Something times something. That's what our goal is. That's where we're going. So what is our greatest common factor? Well, first of all, how many terms do we have in this problem? We have 2 terms. We have something minus something. So we want to look at 30x and we want to look at 3 and find out what is the greatest common factor for those 2 terms. What is the biggest thing that those 2 terms have in common that's a factor? Well, we could write the prime factorization of 30. 2 goes into 30 15 times. 15 is 3 times 5. So 2 times 3 times 5 is the prime factorization of 30, and then we have an x. The prime factorization of 3 is just 3. So if we want to find out what do the 2 lists have in common, the 3 is all they have in common. The 3 is all that they have in common. So 3 is the greatest common factor. Remember again, factors are things that are multiplied together. So what is something that multiplies to make 30 that also multiplies to make 3? We say that 3 is not multiplied times anything. Isn't 3 3 times 1? So the first term is 3 times something, and the second term is 3 times something. So 3 is a common factor. So what is the first term 3 times? Well, if we look at the remaining factors, the first term is 3 times 2 times 5 times x, or 3 times 10x. The second term, if we look at the common factor, 3 is 3 times 1. So we rewrote each term in times of the common factor times something else. The common factor times something else. We can check, does that product make 30x? And it does. Does that product make 3? And yes, it does. So now that we have expressed both terms by their common factor, we want to pull out what they have in common. We're going to reverse distribute. So we're going to put their common factor in the front, and then we're going to list what's left. That first term is 3 times what? It's 3 times 10x. That next term is 3 times what? It's 3 times 1. Now, how do I check to make sure that's the correct answer? I would just distribute it back out and see, is that equivalent to what we started with? Remember in the last chapter we looked at distributing. If we have something in front of a parenthesis, that gets distributed to each of those. So 3 times 10x is 30x. 3 times 1 is 3. That's what we started with, so that means that is the correct factorization. That's the correct way to factor it. So factor just means it's written as a product. So here we want to factor these. So we want to find out what is our greatest common factor. What number goes into 12 and a 3? Well, 3 goes into both of those. And how many y's do we have in common? We have at least 2 y's in each term. So we want to express each term as 3y squared times something. 3y squared times something. Well, the second one's easy enough. 3y squared is that term. So what times 3y squared makes 3y squared? Well, anything times 1 is itself. So that last term is just 3y squared times 1. Now, what times 3y squared makes 12y to the 7th? Well, 12 is 3 times 4. Y to the 7th is y squared times how many y's? Well, when we multiply those together, what do we do with the exponents? We add them. So 2 plus what makes 7? Well, 5. So y to the 5th. In other words, if we take 2 y's out of that, how many y's are we left with? We're left with 5. If we divide out a 3 from that, what are we left with? We're left with a 4. So if you wanted to, you could check and verify that that product makes 12y squared, that product makes 3y squared. So each term is expressed in terms of the common factor times something. Now we haven't finished factoring it because we want to, on the outside, to have just a product. If we have a product on the left, a product on the right, but a plus in the middle, then we're not actually factored yet. We have broken down each term, but we're not factored. So we put our common factor out front. We undistribute. You can think about it as say, well, we have 3y squared that has been distributed to both terms. So what has 3y squared been distributed to? 3y squared has been distributed to that. 3y squared has been distributed to that. So that's what we put on the inside. 3y squared is being multiplied times this. 3y squared is being multiplied times 1. So this is factored. Yes, there is a plus on the inside, but in the bigger picture, on the outside, we have something times something. Something times something. So that is a product that is factored. As long as there's no adding on the outside of parentheses, that's factored. Okay, this one has 3 terms. So let's look at factoring it. What do we have in common? All of these have a 2, and all of them have an x. So that first term, 6, is 2 times 3. We have 1x out front already, so we have 5 more. If we put 2x out front, 4 is 2 times 2. And if we have 2 x's and 1's out front, we need 1 more. And then 2x out front, 8 is 2 times 4. And if we already have an x out front, we don't need any more. So we've put what they have in common in the front. So we're going to undistribute that 2x. What is 2x being distributed to? 2x is being multiplied times 3x to the 5th. 2x is also being multiplied times 2x. And then 2x is being multiplied times 4. So we've written the common factor in the front, and then what 2x is being multiplied with on the inside. Okay, here we essentially have two terms. We have something plus something on the outside. Now we have some adding on the inside too, but we have something plus something. Now, for a moment, ignore the fact that um, that's something messy. So those two boxes, those are something that each term has in common. So we can take that box and put that box in the front and say, what is that box being distributed to? That box is being multiplied times y, and that box is being multiplied times 3, because those things are the same thing inside that box. So what is inside that box, or those boxes? Inside those boxes is x squared plus 9. That's the common factor. Each of those two terms have x squared plus 9 in common. So if we undistribute x squared plus 9 and put it in the front, then the next parenthesis tells us what is x squared times. It's times y, and it's times 3. So we just put the common factor in the front, and then put what is that common factor multiplied to. Now, some of the next problems deal with what if our leading coefficient is negative. So if we look at 3x and 12, their greatest common factor is 3. 3 goes into both of those. But if our leading term is negative, we're also going to pull a negative sign out with it. When we have a polynomial, we typically don't like the leading term to be negative. So if it is negative, we're going to factor a negative out. So this time I'm not going to show that intermediate step just for practice. So if we want to say, well, if we put our common factor of negative 3 out front, what do we have left? So we're just asking ourselves, negative 3 times what makes negative 3x? Well, that's negative 3 times x. And then negative 3 times what makes negative 12? Well, first of all, what are our signs? A negative times what? Negative times what will make a negative? Well, negative times positive. And then 3 times what makes 12? Well, 3 times 4 makes 12. So negative 3 times x, yes, that's negative 3x. Negative 3 times positive 4, yes, that's negative 12. So when we pull the negative 3 out, that is what we're supposed to have on the inside there. So I think this is the last one we have here. Oh, I got 2 more. If we have 4 terms and they don't all have something in common, then we do something that's called factor by grouping. And factor by grouping does not always work, but sometimes it does. So what we're going to do is we're going to group the first 2 together and pull out what they have in common. And then we're going to group the second 2 together, or the last 2, and pull out what they have in common. So for the first 2, if we take an x squared out, we're left with an x there. X squared times x is x cubed. And if we take an x squared out here, we're left with a 9. In the second parenthesis, if we take a 9 out of the first term, we're left with an x. And for the second term, 9 times what makes 81? Well, 9 times 9. And then this is like a problem a couple back. This is a term, this is a term. They both have something in common. They have that parenthesis in common. So if we undistribute that parenthesis, if we say what is x plus 9 distributed to, x plus 9 goes to an x squared, x plus 9 also goes to a 9. We don't write two different x plus 9s because if we were to get rid of the parentheses, we would distribute. X plus 9 goes to both of those, to an x squared and to a plus 9. And then lastly, we have this one. They don't all have anything in common, so we're going to group those two and those two. So for the first two, 7 and 3 don't have a common factor other than 1, but both terms have at least a q. Both terms have at least a q. So out of the first term, if we take a q out, we still have a 7, and if we take a q out of that, we have another q. So q is being multiplied times 7q. For the next term, if we take a q out, q is being multiplied times 3 and times p. So you could check by seeing, does this product minus this one make the first two terms? And yes, it should. Now if we look at the last two, those don't have anything in common. There's not a number that goes into both coefficients other than 1, and q and p are different letters. So our only common factor is a 1. And notice our first term is negative, and we mentioned a moment ago that we don't like our first term to be negative. So all we're going to pull out is a negative 1. So we're going to say negative 1 times what makes negative 7q? Well, negative times what sign makes a negative? Well, negative times a positive. And then 1 times what makes 7q? Well, anything times 1 is itself. So what times 1 is 7q? 7q. 1 times 7q is 7q. Now to get the 3p, we're going to say negative 1 times what makes a positive 3p. So negative, what does our sign need to be? A negative times what sign makes a positive? That would be a negative. And then 1 times what makes 3p? Well, 1 times 3p makes 3p. So when we do that, notice that our parentheses match. So out of the two terms, the parentheses are the common factor. So if we take that common factor out front, instead of writing the common factor two different places, if we put the common factor in front of the parentheses, that parenthesis goes to a q, and that parenthesis goes to a minus 1. So that's our factorization.